Okay, so we all eat. We do it every day. But have you ever really stopped to think about what happens after you take that first bite? Well, it's the beginning of this incredible 30-foot journey that powers literally everything you do. It's this amazing piece of biological engineering, a system that takes, a sandwich or a salad and transforms it into the fuel and the actual building blocks for your body. So, come on, let's follow the food and see exactly how it all works. So this is our roadmap. This entire pathway from start to finish is called the alimentary canal. You can think of it like a biological highway with a bunch of really important pit stops, and each one has a very specific job to do. Our journey kicks off in a place that's way busier than you'd think, your mouth. It's not just for tasting. Oh no. It's basically mission control for digestion, and it launches an immediate two-pronged attack. So on one hand, you've got mechanical digestion. That's your teeth, the heavy machinery, physically crushing and grinding food into smaller, easier-to-handle bits. And at the exact same time, chemical digestion starts, with saliva jumping in to start breaking things down on a molecular level. And our teeth are total specialists. We're what scientists call heterodonts, which just means we have different teeth for different jobs. Right up front, you've got the sharp incisors for cutting. Then the pointy canines, they're perfect for tearing. And way in the back, the big, flat molars are the grinders, just pulverizing everything into a paste. Now let's get into that chemical action. See, your saliva is way more than just water. It's loaded with this powerful enzyme called salivary amylase. The second you bite into a piece of bread or a potato, this enzyme gets to work, breaking down those complex starches into simpler sugars right there in your mouth. And just how much work is your mouth doing? Well, get this. Every single day, you produce enough saliva to fill up a whole water bottle. Yeah, that's a constant flow of digestive power, always ready for your next meal. All right, so once you swallow that chewed up food, which is now a little lump called a bolus, it travels down the esophagus. And its next destination, a pretty dramatic plunge into the super intense acid bath of the stomach. And you can forget thinking of the stomach as just some passive bag. No way. This thing is a dynamic, muscular blender that churns and squeezes and mixes everything with these potent gastric juices to just keep that breakdown process going. So what makes these juices so powerful? Well, the stomach lining is like a factory of specialized cells. You've got parietal cells pumping out hydrochloric acid to kill off any nasty bacteria. Then, chief cells release this inactive enzyme called pepsinogen. And, this is key, mucus cells produce a thick layer of mucus to protect the stomach from basically digesting itself. It's a pretty incredible balancing act. And that acidic environment is the absolute key for digesting protein. The hydrochloric acid basically flips a switch on pepsinogen, turning it into the powerhouse enzyme pepsin. And pepsin is a protein-busting specialist. It immediately starts unraveling all those complex protein chains from your meal. Okay, so after a few hours of all that churning, the stomach has turned the food into this soupy liquid called chyme. Now, this chyme is ready for the main event, a trip to the intestinal powerhouse, where the real, serious work of absorption finally begins. Now, as crucial as the small intestine is, it really can't do its job alone. It has to call in some serious backup from a couple of major helper organs. The intestine has this amazing tag team helping it out. First, the liver produces bile, which gets sent in to break up big blobs of fat into tiny, manageable droplets. And at the exact same time, the pancreas sends in this powerful cocktail of enzymes to finish off the digestion of carbs, proteins, and fats. Protein digestion is a perfect example of this teamwork. Remember how pepsin got the party started in the stomach? Well, now the pancreas sends in another enzyme called trypsin to keep the work going. And then, finally, the small intestine's own enzymes make the final cuts, breaking those proteins all the way down into their building blocks, amino acids, which are now finally ready to be absorbed. But how does all this absorption actually happen? I mean, what's the secret? It's all about surface area. The inside of your small intestine isn't smooth at all. It's covered in millions and millions of these tiny finger-like projections called villi, and even those are covered in even tinier, microvilli. And all of those little folds have a massive impact. I mean, if you could somehow magically flatten out the inside of your small intestine, it would cover an entire tennis court. Seriously. This incredible amount of surface area is what makes it so incredibly efficient at absorbing all the nutrients your body needs. So with all the good stuff, all the nutrients absorbed, what's left of our meal moves on to the final stop on the tour, the large intestine. Its main job isn't really digestion anymore, but a really crucial final processing phase. The number one role of the large intestine is water conservation. It's basically a master recycler. It's incredibly good at reabsorbing water from whatever indigestible stuff is left over, compacting it into what will eventually become waste. But it's also a bustling ecosystem. The large intestine is home to trillions of helpful gut bacteria. And these microbes are not just hanging out, they're actively helping us out by producing essential vitamins, like vitamin K and some B vitamins, before the final waste gets stored for elimination. So when you really step back and you look at this whole amazing process, it becomes so clear that our digestive system is just an incredibly intelligent, fully automated factory. So let's just put it all together real quick. See how the breakdown for each nutrient kicks off in a different spot? Carbs in the mouth, proteins in the stomach. But look where they all end up for the finale, the small intestine. That's the central hub, the main stage where all nutrients get fully broken down and finally absorbed into your body. And this whole system isn't just for the big nutrients. It's absolutely vital for absorbing tiny but powerful things like vitamins. Just take vitamin B12. It's essential for your nerves and blood cells. While it can only be absorbed if it links up with a special protein called intrinsic factor, which is made all the way back in the stomach. It's a perfect example of how every single step in this journey is connected and vital for your health. This whole intricate 30-foot journey happens inside you every single day. A silent, automated factory that turns your food into your life. It masterfully breaks down whatever you give it and uses those pieces to build and power you. So really, the only question left is, how are you going to choose to fuel this incredible system today?